Visit us at www.agstech.net. Powder metallurgy is a fascinating field that involves creating metal parts from powders. It's like making a sandcastle, but instead of sand, we use metal powders. These powders are carefully selected and blended for desired properties. The process involves pressing the powder into a desired shape and then heating it to bond the particles. The beauty of powder metallurgy lies in its versatility. We can create complex shapes that are difficult or impossible to achieve through traditional machining. This makes it ideal for industries like automotive, aerospace, and medical, where precision and complexity are paramount. Powder metallurgy parts are known for their durability and strength. They can withstand high temperatures and pressures, making them suitable for demanding applications. Plus, this method produces minimal waste, making it an environmentally friendly manufacturing process. The first step in powder metallurgy is pressing. Imagine filling a mold with metal powder and then using a powerful press to compact it into the desired shape. That's essentially what happens. The powder is carefully measured and poured into a die, which is a mold that gives the part its shape. To help the powder flow smoothly and bind together, we often add binders and lubricants. Binders act like glue, holding the particles together, while lubricants ensure even distribution of pressure during compaction. The press then applies immense pressure, typically thousands of pounds per square inch, to form a solid green compact. This green compact, although it looks like a finished part, is still relatively fragile. The particles are just pressed together and haven't bonded yet. That's where the next crucial step, sintering, comes in. Sintering is like baking a cake. We need heat to transform the loose powder into a solid, cohesive material. The green compact is placed in a controlled atmosphere furnace and heated to a temperature below the melting point of the main metal component. This heat causes the metal particles to diffuse, meaning they move slightly and bond with their neighbors at their points of contact. This bonding process increases the strength, density, and overall integrity of the part. The result is a solid, durable component with the desired shape and properties. Sintering time and temperature vary depending on the material and desired properties. It's a delicate process that requires precise control to achieve optimal results. Beyond the basics of pressing and sintering, powder metallurgy offers a range of advanced techniques for specialized applications. One such technique is isostatic pressing, where the powder is compacted uniformly in all directions using a fluid medium. This method is ideal for creating parts with complex geometries and uniform density. Another advanced technique is metal injection molding, or MIM. In this process, metal powder is mixed with a binder to create a feedstock that can be injected into a mold, much like plastic injection molding. This allows for the creation of highly complex and intricate parts with excellent precision. These advanced techniques highlight the versatility and capabilities of powder metallurgy, making it a preferred choice for a wide range of industries seeking high-performance materials and complex designs. Visit us at www.agstech.net.